Bless you. Okay, so in geometry, up to this point, we've talked a lot about two-dimensional figures. And right, we've just corrected composite figures, area of a composite figure. So now what we're going to do is we're going to our next string of lessons in the near future are all about three-dimensional figures. So this is heavily vocab based because when I teach you the other things in the near future, they are going to be, I'm going to be using a lot of these terms. And so when I use them, I want you guys to be able to understand what I'm talking about. All right, so three-dimensional figures. Here we go. Kind of move fairly quickly. If you have questions, you need to slow down. Make sure you raise your hand. All right, here we go. Our very first word is face. Everyone? Face. All right, this isn't like the thing that's in the front of your head. All right, this is a flat surface. It's the side or base of a prism. So if you have a prism, all right, so for example, that prism right there is a rectangular prism, okay? A face is basically each of the sides. So you think about it, right? If you're rolling die, right, for singular for dice, if you're rolling a die, okay, how many different numbers can pop up? 6, right? It's because there's 6 faces on a cube, all right, or a rectangular prism. So those are all faces, all right? So that's what it's talking about. So each flat surface is the side or the base. So there is one type of face that is a little more important than the rest, I guess you'd say, especially when it comes to prisms, and that is something called a base, or bases. Everyone? Bases. All right, so here's what a base is. The book says the bases of a prism are any two parallel congruent faces. Now, the one thing is on a rectangular prism, right? All of them have, you talk about a congruent face. It's parallel. It's like a twin on the other side. Okay, well, when it comes to rectangular prism, you have a lot of sides or faces that can be considered bases. But for example, if I take something like this, what's that shape called? Triangular prism, right? And it gets its name, we'll talk more about this in a bit, but it gets its name from its bases. You have a bunch of rectangles, but the two ends that are congruent, that are the same size, obviously, because they're congruent and they're parallel, those are the bases. And so a base, these are the bases, the two triangles, while the rest of them are considered just faces. Okay, so with that said, let's talk about our next word, edge. Everyone? Edge. So here's what an edge is. This is what your book says it is. It's where two planes intersect in a line. Where two planes intersect in a line. Okay? So basically it's where, if you're talking about a plane, it's one of the faces. Think about it where two faces hit each other. All right? Well, it's kind of almost common sense if you think about it. Probably what you thought was an edge is an edge. Here's an edge right here. Here's an edge. Here's an edge. Here's an edge. Okay? Those are because this plane here, this side, and that other side is hitting right here. And that's called an edge. All right? The next is vertex. Everyone? Vertex. So here's what a vertex is. This is where three or more planes intersect. They use the word intersect. Where three or more planes intersect in a point. Now we've talked about angles, and we've talked about vertexes and angles, right, where the two lines come together. All right. However, when you're talking about a three-dimensional figure, it's kind of like that, but they're actually saying three or more planes, basically three or more sides hit. Well, think about it. Wherever three or more sides hit is just one of the corners. Each of these corners are considered a vertex when it talks about a three-dimensional figure. All right, and then this one here on this page, diagonal, everyone? Diagonal. Now, diagonal, we'll come across the word diagonal in the lesson. I don't believe that the book has said it as like a formal vocab word. So that's why I have a little asterisk next to it. So it's probably not in your notes either. But it's something you need to know to do your homework tonight. So here's what diagonal is. This is a line segment that connects. Here we go. It connects two non-consecutive vertices. Vertices are, of course, plural for a vertex. So you have one vertex or two or more vertices. So if you want to know what that is actually saying, if I connect this vertex with this one, that's considered two consecutive. And an edge is actually connecting them. Over here in this one, there's an edge that connects here. They're consecutive. But what about this and this? If I connect those two, that's considered a diagonal. They're non-consecutive, meaning if you go on the edge, you'd have to go through a point to get to the other point. So that's what it means by non-consecutive. So a diagonal looks something like that. All right? And you kind of think about it, right? What we probably think of as diagonal, that's kind of the line it's making. Okay, I know I went pretty fast, but we have more to go. So any questions on this page before we move on? All right, here's the next one. All right, solids, everyone? Solids. So when you see the book use a name like this, a solid, it's a three-dimensional figure. So you're going to see three-dimensional figures also called solids. I probably should have started with this page here, but that's okay. Some of those last ones will make a little more sense. But you already have an idea of the prism. So here we go. So there is a solid called a polyhedron, everyone? Polyhedron. Here's what a polyhedron is. It's a solid, three-dimensional figure, with flat surfaces that are polygons. So each side of it is a polygon, and that's what they call a polyhedron. So a solid is a three-dimensional figure. Polyhedron is a special kind of solid. It's one with flat surfaces that are polygons. Okay? The next one is prism, everyone? Prism. This is a polyhedron with, and we talked about this earlier, two parallel congruent bases in the shape of polygons. Right? The congruent bases we now know are also called faces, but the two bases that are the same. That's what makes it a prism. So a special polyhedron is called a prism, and a prism has two parallel congruent bases. So you might see this as a cylinder, a triangular prism, obviously a rectangular prism, because the opposite sides are parallel and they're congruent, same size. So that's what a prism is. Then you have something called a pyramid, everyone? Pyramid. Okay, so we think we all know what a pyramid is, but here's mathematically what a pyramid is. This is also a polyhedron, right? You have a prism and you have a pyramid. A pyramid is a polyhedron. It has a polygon for a base and triangles for sides. But instead of the base having a congruent base on the top, for example, if you take a look, what's on the, so if this is, let's say, a square down here, or a rectangle, what's on the opposite end? A vertex. That's what makes it a pyramid, and it creates triangles along the sides. Now we have a cylinder, everyone? Cylinder. So a cylinder is a solid that has two parallel congruent bases, okay, usually circular, connected with a curved side. So a cylinder, you know, I was joking with my other class today. I said, well, we could almost call it a circular prism, even though it's not, because the bases are circles, okay, but they give it a special name called a cylinder. So the bases, the congruent bases, are circles, and it creates the curved side. Okay, and then a cone, everyone. So everyone sometimes kind of forgets, they think a pyramid and a cone are pretty much the same, but they're not. A cone is a three-dimensional figure with one circular base. Remember, the pyramid had a polygon for a base. A cone has a circle for a base. And this is a curved surface, connects the base and the vertex. So you have a bottom base that's a circle, and the top is still a vertex. Kind of like a pyramid, how the top's a vertex in a pyramid. All right. Questions on that one? There is more, I told you guys. Not too many, though. We're almost done. All right, here we go. The next one is called a plane. Everyone? Plane. So you guys have seen, we talked about a plane earlier, right? When I called them like their faces. Well, here's what, when you hear about a plane, this is a two-dimensional flat surface that extends in all directions and contains at least three non-collinear points. Where have we seen a plane before in this class? Where have we seen a plane like this? Coordinate graphing, right? You're graphing the different quadrants. That is considered a plane. The number lines, think about it, the x and y axis, they keep going forever, right? That plane extends. It's a flat surface and you're putting points on that plane, okay, different quadrants. So that's kind of what the plane is. So here we go. Here's a couple other words. Cross-section, everyone? Cross-section. So this is the intersection of a solid and a plane. We're going to be talking about cross-sections today. All right? So if you hear the word cross-section, this is where you have a solid. We talked about all those different solids a bit ago. And a plane actually goes through the solid. All right? And it actually creates a shape, which we'll be talking about. Okay, and then the next one is skew lines. Everyone? Skew lines. Okay, this isn't in there either, but you'll see it in your book. These are lines that don't intersect and are not coplanar. Lines that do not intersect and are not coplanar. And we'll take a look at some shapes here in a second that goes with that. Okay. So here we go. We are done with vocab. Woohoo! Let's go ahead and grab our books and let's flip over to page 577. 577. Okay, go ahead and grab your paper if you haven't done so already. Label it. Name, date, period. Okay, I'm going to go ahead. Number 2 you guys have in the book. All right, I'm going to go ahead and draw it, or I can kind of draw on the paper since I can't write in the book. Okay, here we go. On some of your homework, all right, on 1 and 2, obviously, and then down below on 7, 8, 9, 10, 11, and 12. All right, they have very similar directions. It's actually testing on your vocabulary. That's what these problems are. All right, so here's what we're going to do. For number 2, if you take a look, it says identify each figure, name the bases, the faces, the edges, and the vertices, then identify a pair of skew lines. It's a lot to go into this. All right, so here we go. By the way, I'm not looking forward to correcting this homework assignment. All right, here we go. So the very first, we'll say step 1 is where you don't miss anything for sake of your homework grade, use your directions, all right, and write down the different parts that you need to identify. So they have the name of the figure. I'll just put figure and I'll name it. Okay. We have the bases. We have faces, just looking at the directions. We have edges. We have vertices. And then we have skew lines. Okay. Step 2 is, of course, answer each one. So you're going to need to use your vocab if you forget what these are. So here we go. The figure on number 2, if I take a look right here, at first, my very first gut feeling is a triangular prism. But here's the problem. Triangular prism, a prism has to have congruent bases that are parallel to each other. There are no two twins, right? That's what congruent means. There are no two twins on there that are congruent. What this is this has a base on one end and a vertex on the other. This is a pyramid. Now, you're going to have to name the different, of course, going back to this, right? You're going to have to name, of course, the different polyhedron here, a prism or a pyramid. And then you have to give an adjective describing it. So that's, think about it. If it's a prism, right, it's a triangular prism, a rectangular prism, right? That's what you call them. In this case, I have a pyramid, and I take a look. Well, what kind of pyramid is this? Well, every single side on this is a triangle. This is a triangular prism. I'm sorry, my fault. Triangular pyramid. Okay, adjective triangular, since all the sides are triangles, which means that the bases are triangles. So the base or bases are triangles. Now, I want to go ahead and do the faces first, because all the sides are faces. Okay? So here's what you're going to do. I'm going to name each one of these faces. In this case, let me name this left face first. I can call it TQR or QRT or QTR. All I have to do is name it by its 3 vertices. But I can't leave a vertex out, a vertex out. Okay? So I'm going to name it, and they all have to be capitals because these aren't variables we're dealing with. I'll just call it QRT. There's that face. I'm going to now name this face RST. RST. And remember, when you name a face, especially if it's not a triangle, you need to go in order. All right? So loop around the perimeter of that to be able to name it correctly. Now I'm looking at this back side here. It's QST. Now we can't forget the bottom. QRS. QRS. Okay, now look what bases are. It says the bases of a prism are two parallel congruent faces. Here's the thing. A triangular pyramid, okay, or I should say a pyramid, the base, the opposite of the base is the vertex. But here's the thing, and this is why I wanted to do this one with you. QRS could be a base, but if I took this, you have to use your imagination a little bit, and I flipped it over to its side, you would have a different pyramid, with S being the top vertex. Every single one of these sides are actual bases on here. Okay? Usually it's the opposite side, but because it's a triangular prism, I keep saying prism, triangular pyramid, okay, it creates all of these sides. So this one is easy to write down, but it might be hard for some of us to understand. This is kind of special. Every single one of your faces happen to be bases. QRT, RST, QST, and QRS. Okay, now for the edges. I have to name all these edges. Here we go. The edges, remember, are these lines. I'd name them by the line segments from vertex to vertex. So, for example, this line right here is QT. Now, when you're naming a line segment, here's how you do it. You put a line up above. This is, I'm just going to go up the sides first. RT. Capital R, capital T, line segment. This is ST. Capital S, capital T, line segment. So I have those three. Here we go. This one right here, RS. RS. Here's this one. QR. QR. And this back one here that's hidden is QS with a line segment. Now the vertices are pretty easy because they're just the points. They're all the letters. So Q, R, S, and T. Those are all our vertices. Now for skew lines. Remember, skew lines said lines that do not intersect and are not coplanar. So here's what this means. Okay? They don't touch each other and they're basically not parallel with each other. Well, I'm just going to choose one. RS. There's a lot of answers, guys. RS and it can't be QR because that would hit that point. Can't be QS. It can't be TR or TS because those also hit the R and the S. A skew line is this line right here. QT. Take a look. They're not parallel. They'll never cross each other. They're on different planes. They're skew lines. Okay, normally I'd give you guys time to try one out. Hopefully you took good notes. You have those. You have your vocabulary. All right. I do want to move on to another type of problem. So this is where I want to show you guys the video. All right. So I'm going to show this in case you need to watch what we're taping right now later. All right. So this is the website if you want to watch the video over. All right. It's off of YouTube. All right, so let me go ahead. I'm going to show it here in class, but I want to give you guys a heads up. This video gives you an idea of what a cross section is. Okay, it's a bunch of high school students that got together to kind of try to be creative, try to be kind of funny, even though it's not too funny. It's kind of corny funny, but that's kind of what they're kind of shooting for. They're trying to be corny. But it gives you a rough idea of what cross sections are. All right, so here is what I want to show you guys.